Good morning, everybody. My name is Jason Fox. I'm the Senior Technical Evangelist of the FIWARE Foundation, and the subject for today's Wednesday webinar is language maps, multi-language support in NGSI-LD. So let's see what we're going to be talking about. Firstly, we're going to briefly describe what the problem, or one of the basic problems with languages and multi-language definitions are understanding exonyms. Which is working out, what the names of various places are, and then explaining why this is a problem, and trying to come up with a reasonable solution. As you probably realise, FIWARE doesn't come up with solutions on its own. What happens is that the ETSI committee, FIWARE, the users of the FIWARE community, look towards existing best practice to try and get around problems such as these, and as they are becoming in common usage, you start moving on towards something which is defined by the specification, defined by recommendations, or depending on the level of degree of recommendation, it's either a must or it's be rather nice to do this, and then you move on to everybody following the same way of doing stuff. Particularly when you're talking about data sharing scenarios, we all need to be following the same sort of paradigm. And for NGSI-LD, it is important that the context, the bit which the machines read, the at context file, is also well defined so that they can understand what languages are. NGSI-LD 141 is bringing in this thing called language property. It's currently not supported by the context brokers. It's on the roadmap for all context brokers because it's actually in the ETSI spec. And should be available in, say, 6 to 9 months' time, typically. But there are workarounds which can be used using ordinary properties. But I want to explain how language property will be used, because that will be the way to do it going forward. And this brings us on to how to deal with multilingual queries and responses, with a few more acronyms coming through, like language tags or content headers, which is where you should be defining what language you want and why. And then finally, there are certain things which aren't explicitly done by context brokers. However, there are proxies or a workaround outside of the context broker which needs to be done in order to deal with these. Now, obviously, that is your code rather than the context broker code. However, there are, again, standard ways of dealing with this, standard ways of sorting these things out, which and things like semantic markup of complex objects, for example, is quite easily done within standard data models. So it's going to be a recommendation which is can be applied today. So the first bit, the language property, is coming soon, but is definitely coming soon, and the rest of it is all available today. So language maps, why do we need them? Well, you need to understand that the world's a complicated place, and many different places have got equally valid names in different languages. You look at the central square in Brussels. It's got two different names, one in Flemish, one in French, Walloon, and you can see it's either Grand Place Bruxelles or Grote Markt Brussels. Now, these are both equally valid names, and if you you don't want to go into your model to give it a name property which is name in French or name in Dutch, because obviously if I'm in Berlin, I might not have a name in Dutch. I don't want to add that particular attribute into my name. It's the name which is the thing which is changing, and it's particularly talking about strings here. The whole issue about language maps is talking about simple strings which have got different names in different language. That is basically an exonym, Obviously works with landmarks, smart tourism, but another way you could just equally be talking about, say, bus stops in Bilbao, where you could have both Spanish and Basque as being equally valid languages. A lot of local authorities are multilingual. A lot of countries have got more than one national language. So you've got to think, whenever I'm talking about names, how do I deal with those? This is the standard smart data model's place of interest. We're going to look at landmarks today, and you can see that it doesn't describe what the or it doesn't mandate what the values of the various strings are going to be. An alternate name, it says it's text, but it could be a variety of different it's property basically. But the interesting one here is to look at category. I've highlighted category on the third line. The allowed values are defined by another well-known body, factual taxonomy, which extends the categories for the specification. And for our particular case, landmark, it's 107, but it's a little bit more than that when we look into it. It's not for the data models to decide this. It's for the context broker to actually deal with the information as necessary. And this is what the problem is. So we've got some random beach in Spain, and it's got a name called Playa de Concha. But then, what is the name of the central square in Brussels? Well, it's both, isn't it? It's got just as much validity being Grand Place as it has being Grosse Marque. So there needs to be some sort of markup which will allow us to say this is the name in French, this is the name in Dutch. Fortunately, there already is a standard out there for how to deal with multi-language information. You define a language map. This is going back to factual, saying that what that category 107 actually is that it actually has got an object called labels in here, which has got an array of languages, which have got EN, DE, FR, and so on and so forth. Now, those labels have got a meaning under BCP 47, saying which languages those apply to. So these are common naming for the various attributes.
I see, Lucas.
Common naming for the various attributes, and it means that you can do these from well-known names. If you are using the NGSI v2, you could use the dot syntax to say labels.en to get the English word coming back. If you're using NGSI-LD, it's square brackets. But perhaps more importantly, the same concept of a language map is available in JSON-LD. Now, JSON-LD is the basis of NGSI-LD. That's what the LD bit, linked data, is. So it already has got a definition of how to mark up language. The same things occurs with, say, other taxonomies, but you can see that the various different words for ninja as an occupation have been defined, and again, it's in a JSON object with these languages: Japanese, English, Czech, on the right hand side. Now, looking at the context, now this is where we start moving into the linked data stuff. You need to define a container as an language. Now, this is possible at the moment within your own context for the specifically for your use case. However, what will be happening with the next, it was already 1.1 version of the NGSI-LD specification, is that the same thing will occur within the core context. So it will be able to mark up various attributes as being language attributes. At the moment, if you can't use language attributes, everything I'm saying would actually work with ordinary properties, except that you wouldn't get all the flavor of multi-language support, which comes later on. So at the moment, there already are different classes of property. You've got ordinary properties, which just treat the value within the entity as being just a straight value. However, there's also geo-properties. Geo-properties are a bit different, and it sets up the attribute as being read as a longitude-latitude pair, which is ordered and is of a type. In this case, point is whatever the GeoJSON type. So there needs to be within the core context a mechanism. It's going to be called language property, to be able to take one of those language map arrays like Grand Place, Grotemark, French, and Dutch, and be able to sometimes treat it as a property and sometimes treat it as an object, because obviously you might need to replace this these values or something like that. So it's kind of half and half is where language properties are going to be. Is that they are basically, if you can treat them the same as geoproperty, you'll be fine. The updated core context has got this additional line defining language properties, because obviously computers are dumb. Computers don't understand what we mean by a language map unless you explicitly put it into the context. So there's going to be a new language property and a new language map attribute, which is going to be put into the system. You notice coordinates have also got a special defined value. If you go back, if you read the value normally is just, as I said, object. However, coordinates are in a container of type list, for the simple reason that the ordering of the coordinates is important. You can't change around the latitude and longitude, but for ordinary values, that's perfectly possible. So this is the JSON-LD way of specifying that this particular attribute is a set of language properties. Now, you can see on the right-hand side that we have some ordinary properties like category and address at the top, and they are just read in as values. Then you have the location, which is saying, I'm already a geo property, and it comes back as a point, and you can do things like geoqueries on it. Now, you can understand that if we start having something called a language property, we're going to be able to do linguistic type queries over this particular map. Now, as I said, if you want to just use NGSI v2, you can just key directly on the sub attributes using the dot syntax. However, there'll be some more clever stuff coming in the next few months. Creating an entity with a language property, it's a post like you'd expect. It's just adding in a property, and you just set the type to language property, rather than just plain property. It's a kind of subclass of property. Unlike ordinary properties, it does not have a value sub-attribute. It's got a language map sub-attribute because it needs to be treated differently. And like any other attribute, it may have metadata. You can add observed at, but you can't add unit code. This makes sense because language map particularly is used for simple strings. It's not objects, it's not values, it's not numbers, and therefore it makes absolutely no sense to say it's what the units are, because it's always going to be simple strings. So language property is specifically there to try and help queries over simple over strings in multiple languages. So it's a rather specific area which will need to be dealing with. When you read a multilingual data, the response defined by JSON-LD will depend on the at context at language, which is defined in your request. If you remember, the link header will usually say, as far as I'm concerned, I'm using this particular map of the world, this particular definition of elements, and you can, in your at context, specify a language. So you can see, according to JSON-LD rules, if I just say, give me the key values, it will, by default, it will say at language and at value for each element. However, if you specify that, oh, give me the key values, and by the way, as far as I'm concerned, the world is French, it will give language. The first language is a string, and the second one in this at language at value format. So you can see which languages are available. This is following the standard expansion compaction rules for a container as defined by JSON-LD. This is nothing particularly special for NGSI-LD, but of course NGSI-LD is a extended subset. So everything that JSON-LD 1.1 does, NGSI-LD will automatically do. Obviously, your JSON parser will be able to read that, and you'll be able to get the information back. So far, all we've done is we've changed the format of the response because we put something in the header. Not particularly clever, but it's in there already. This is the standard normalized format saying for this particular property we have got the following strings. It starts becoming a little bit more interesting when you add in the new lang parameter in your query. If you, instead of just getting the name attribute, you put name and lang and followed by a BCP 47 code like NL for Dutch, what will happen is that rather than treating the object as a language property, it is now all of a sudden treated like a property. So in this particular case, if you put and lang is NL, it will just return back the Dutch string as a property, a simple string. Now, there's an additional non-rarefied attribute which is returned in the normalized response called lang, which is saying not only am I a string, I am a string in Dutch, I'm a string in French. If you specify a language which is not supported, so for example, in this case, we're asking for lang EN, English, then the context broker can decide which string to return. And in this particular case, it's returned it in French, but it tells you it's returned it in French, saying, I can't support English in particular, but here's the name of the system in a language you're likely to understand. This is particularly useful for places like North Africa. If you're trying to get tourists in from, say, Europe, they tend not to be able to understand the Arabic script. So it would be a lot better to say default to the French language, which is understandable for Englishmen like me, or at least the characters are, rather than showing your Arabic characters for names of places and what have you. So how the context broker decides which language to do is, again, not defined by the specification, but I would assume that brokers would be able to be set up to say, I want to default to French as my main backup. Obviously, it could be random, but it's more likely to be useful. So you'll be able to get back information in a reasonable format. If we do the key values does the same sort of thing as you would expect, in that if you put this lang parameter, then it will be treated like a string. So as far as we're concerned, if we get the point of interest for this place in Dutch, it will be a string with the name Grote Markt. If you put the same thing with French, it'd be a string with the name Grand Place. And again, if you put in a unsupported language, it will just pick one of them saying, the name of this place is Grand Place. If you don't specify a language, obviously it realizes this is a language property, and it will return the standard JSON object with a language map itself, saying all of the names which I have got for this particular attribute are in this particular object. Pick whichever one you want. Obviously, you would use this query to retrieve it into your system, and then your system would be able to work out, yeah, I want to pick up the whichever language, or display the full list of languages as necessary. So you can get the information out as you need. There is a standard for specifying language preferences. So if you go on the internet and start browsing multilingual websites, you'll find that it will default to your preferred language. Mine will be obviously in English, but yours could be in Spanish, French, whatever. And then if they haven't got a version on your preferred language, it will go down to a second level or third level. Now, on the examples I've given so far, with a lang parameter, I have given simple examples where I'm saying, I want this in English, lang equals en. However, the lang parameter should be clever enough to be able to decipher the standard RFC 3282 syntax, which is already in a lot of systems using the accept language header in HTTP. So this is a standard syntax where you would be able to comma separate languages at the same level of preference. So you could say, I want Swiss French or French by having FRCH, comma FR. Or you could actually add in a quality value ranking. This is saying, I prefer this language, but if you haven't got that, give me that. If you haven't got that, give me that. If you haven't got that, give me whatever you've got. Now, according to RFC 3282, if none of your preferred systems are supported, it should return 404, supported. However, that is generally ignored by literally everybody because it's annoying to say, yes, I haven't got anything. And most websites will default to giving you something, which is the star parameter. And I believe this is the case that the way that context brokers will go. Specification will state follow the RFC 3282, but if you prefer Armenian and we haven't got Armenian, then I would expect that a context broker will return something in its whatever language it's actually got. So this is, again, following an existing standard for that language parameter. This means we can start querying for language. This you can already do using using ordinary properties, and it's just use of the square bracket notation, at least in NGSI-LD, NGSI-V2 it's dot notation, so that if you want to retrieve a specific element from a language map, you just treat it like you would do an ordinary object. So it's a name, brackets FR, to get Grand Place. Fine, that will work perfectly well. That's going to say, I am getting one particular value. Of course, you can combine both this new lang parameter with the existing Q parameter. So you can say, give me the points of interest with the name Grand Place and return my strings in Dutch, and it should return Grottemarkt. And if you put a star in a language map property, then that would obviously give it in any language. That is new. That is not currently the way which will work for ordinary properties. So if you were trying to do it with an ordinary property or trying to do it in NGSI v2, then you'd need to have name equals FR Grand Place, or, which is a semicolon, name equals NL Grand Place or whatever, so a wider list of elements. So it will simplify the syntax when asking across multiple languages. The next point is, of course, as you would expect, this is a language property is just defined as a subclass of property. So therefore, it is possible to make it a property of a property, and therefore you can use it in metadata. So if you want to find the historical Dutch name of a point of interest, you can get the old name of Brussels in Dutch, and it will return a value. This is saying that the Q parameter is working in the usual fashion, and doesn't do anything particularly new. Again, you could have, in the same fashion, you can have metadata associated with a language map or language property. You can have language properties as metadata of other attributes. Let's move on to another area. This is internationalization, dates and currencies. These cause issues with NGSI data today, and there are standard ways around this, and reasons why we do it the way we do it. Context brokers are a mechanism for data exchange. So because my system is going to be isolated from your system, and we want to be able to talk to each other, there are certain rules. So strings are always Unicode strings. Dates are always ISO 8601 dates. And it's a very bad idea to try and push your currency symbol or your amount into your data. Your data is just your numbers. So what you should do is you should have a cost of, and it's just a number. In this case, it's 1500, because it means I have one version of that value. Again, my date is just going to return as an ISO 8601 date. Now, this what you don't want to do is to specifically have an attribute, say, cost with currency symbol, or date with date in Islamic date format, or date in French, or whatever, because that is breaking your data model for a start, because nobody else will have these attributes, and it also is trying to stuff data things into the context broker, which isn't related to a context broker. It is trying to use it for internationalization where it shouldn't be done. It should be elsewhere in the system. So just use your context broker for context broker things. What you need to do is you need to push this to a proxy outside, because it's not always somebody else's problem. So take, for example, this date. I'm going to try and make my date into an Islamic date because it nicely changes the year. I can just get the date from my context broker using a simple key values selection. However, I can then use standard libraries for change the data outside of the context broker, saying this is not a context broker problem. This is a problem for the components which surround the context broker. Obviously, they are receiving data in NGSI format, but they then need to, in this case, it's doing a Canadian Islamic date, I think it is, and in a specific format to get the information out. So you use standard libraries outside of your system, because you know that the data which is coming from your context broker is always going to be dates. UTC dates. Collation and sort order, same sort of issue here, with slightly different advice. Cultural strings are very, very language specific. You can see there are different examples here where you want to be able to ignore accents in French when you're trying to doing sort order. So you might want to be able to match élève with the accents on it, or in German, then you've got the U with umlaut, should be a UE, and then Czech considers CH to be a single phoneme, a single letter, and then whether you order your accents at the end of the list, or something really weird like Lithuanian, where you have both the accents in the middle of the system and interleaved, and J is in the wrong, so Y is in the wrong place, Y is before J. It's going to get complex. So what tends to happen is that this is going to be a system-specific issue, and therefore, again, it's not something which is done within the context broker itself. The context broker will help, but it's not done within the context broker itself. The simplest way to deal with this, and with NGSI v2 and isolated systems, it is the advice is very simple, which is saying use context brokers for context broker things and use databases for database things. You can take your list of say bus stops in Bilbao, and then you can extract the names of the various stops, and you can push it to a database which has already got an appropriate language appropriate collation set up for it. So you can just then query a database and say, give this back in Spanish ordering, give this back in Swedish ordering. It's very simple. It does rely on a backing database. There was an example which was given in a previous webinar, which I've linked. Put the link up on the screen. For systems where you are not looking at doing federation or proper data sharing, that will do. But there are, of course, disadvantages of that, and that is, I want to be able to push my data to multiple systems. I therefore want to federate, and I therefore want to get information out of multiple systems. This is a typical use case for NGSI-LD. So rather than relying on an existing collation index which is inside your database, you're going to have to build up your own collation system. So it's going to be a case of taking your data, like your name attribute, and then adding in an appropriate element of metadata, a collation sub property, which has got the things changed as necessary. So if you use and these are examples in JavaScript. If you use the normalize function, it will strip out your accents. Or if you want to, say, do the German thing, you can do this replace with your O umlaut to OE and what have you. And of course, there are libraries to do collation or come up with a collation string before you do anything else. Examples in Java and C# there, and actually the Unicode algorithm. If you want to go into the full details, again, link on the screen. This is they're then going to be pure NGSI-LD. And indeed, what you've done here is effectively you have now distributed your collation index, because rather than being a table embedded inside your database, you have now got a collation index which is queryable across multiple brokers. Moving beyond simple strings, this is something which can be done today. This is something which is actually to do with how to define your data models. And again, this is a recommendation from the latest specification. There are plenty of places where you need to have an indication as to what language something is going on in, but it's not actually just the string. It's not just the name of the place. It's just saying, my hotel staff speak Italian is useful information, but or I have booking forms in multiple languages, or we have the same walking tour around the city available in English and German, or we do this reviews in multiple languages, and so on and so forth. You need to be able to keep the standard data model defined. However, you need so you're interoperable across borders, but you need to be able to extend it to be able to give additional information to mark up how the information can be dealt with. So there is a recommendation in the ETSI spec. It's non-normative, so you don't have to follow it. It's highly recommended that you do, because obviously that will be the source of authority for saying, yeah, actually, ETSI say do it this way. It means that you can still maintain the same model across either side of a border. Now, obviously, the picture on the right is an international border. It's a tri-point, but you can imagine that we could just have we have borders between local authorities. Making sure that two local authorities are using the same data model is important, and extending the same data model in the same fashion is important, so that everyone else can retrieve the information from elsewhere. The first recommendation is to use an in-language attribute. Schema.org already define an element which can be added into your local app context. Nothing to do with the core context, it's just your local stuff. And it basically says add another attribute to say this event, this entity is in a particular language. It's optional, obviously, because if I have events in a monolingual country, I don't necessarily need to point out that it's in this particular language. However, you can, because it's a standard name with a standard URI from schema.org, external systems will be able to read that in as saying this is in French, this one is in English. You can obviously move that to a subproperty of a property of a property, and it could go equally go to a property of a relationship. So if you have an entity which is in French, also available in German, English and German, you would add a same as. Again, this is standard defined within schema.org, and that in turn would have relationships which would have an in-language for each value. It allows you to query across multiple systems in a standard without disrupting your data models. So, in summary, language maps are the approved mechanism for multi-language support. It will be rolled out over the next few months. I said about 6 months, 9 months, probably coming through. And it is basically just taking what's come from JSON-LD containers. Now, there are plenty of things which context brokers do not do, and you should not try and force them to do it. So don't try and push dates in dates in Spanish or whatever into your data. Try and keep your data as proper dates, and you can even mark up the at context to say this is a such and such date. So use your context brokers for your context broker things, and don't add in additional properties. Add in either metadata into your property to say it's in language X, or use existing semantic tagging such as same as and in language to indicate the language and origin of equivalence. So thank you very much for attending today, and I hope you've learned something, and enjoy the rest of your day.